Welcome back, everybody, to our second lecture on ancient technologies. This time, moving on from discussion of lithic technology, which was last time, we're going to talk about metallurgy and ceramics. So, once again, we have a few key terms that you'll want to have in your notebooks as we move forward in this lecture: metallurgy, ceramics, cold hammering, kiln, alloys, firing temperatures, smelting, paste, and temper. First off, metallurgy. This is a term that we use to refer to the science and engineering of working with metal. This is one of the very earliest sophisticated technologies after lithics that people appear to have developed, and in some regions actually developed prior to the uh, work in ceramics. But in many instances, the technologies, as we'll see, have some common technical aspects that lead to a frequent association of metallurgy and ceramics in terms of historical technical development. The earliest way that people made tools out of metal was by cold hammering, acquiring a natural nugget of copper or gold, and then using main force to flatten it and create things such as uh, points, awls, needles occasionally. But more frequently around the world, where you see this cold hammering, the one of the primary things that the earliest use of metals is involved with is the creation of ornaments and objects of display, as you can see in this example here. What's interesting is that you can actually tell the difference between metals that have been worked in different ways. If they've been melted and cast, if they've been hammered, if they've been cold hammered after being smelted with thin sections and high powered microscopy. So when we look at these things archaeologically that are recovered and conduct the appropriate levels of analyses, we're not just guessing at how they've been worked. We're actually able to understand that in a very, very clear way and understand the exact nature of the mixtures of different kinds of metals and even source the material many times to its geological origin. One very, very early site that has some remarkable metal work is the site of Varna on the Black Sea coast of Bulgaria, there in Eastern Europe, north of the Bosporus, north of Turkey and Greece, with a shoreline along the Black Sea. That site produced 280 graves. Not all of it has been excavated, but 280 graves were excavated beginning in the 1970s. And radiocarbon dating has shown that those 280 graves all date to just over about 100 years of time. So this isn't something that was a cemetery that was used for millennia. There's a very, very intense period with a huge amount of gold work and metal work. What is also interesting is that it's not the largest site of its kind. Other sites along the same Black Sea coast include hundreds of burials as well. This is one of the classic examples. This is burial 14 from Varna. And they are part of a wider 5th millennium BCE trend towards large cemetery complexes. There's massive amounts of grave goods, especially of metal and exotic stone. What's also interesting, though, is that these ornaments and many, many gold beads, as well as axe handles and other very, very flashy objects, are not evenly distributed. Unlike previous Neolithic patterns that we talked about, these early Chalcolithic, Copper Age, or early Bronze Age societies appear, as we discussed, to have shifted into a pattern where there was a great increase in the amount of social inequality. And these metal ornaments seem to have been one of the earliest ways that was expressed. Here's a beautiful example of a spondylus and stone and gold necklace that was found at Varna. And these patterns often associate themselves with pyramidal hierarchical societies like this. The gold work is not necessary unless you need to show off and show your status difference, or uh, or is that the way that these things developed, or is it that people began to develop more technical sophistication as you have the emergence of artisans and craft specialists in societies? There are different views of this. And we'll talk a little bit more about that here in a second. Ceramics as well are particularly important to understand in this early development of technology. Ceramic production, like metalworking, represents the best example of an additive as opposed to a subtractive technology. Um, in contrast to stoneworking, you have a greater degree of creativity possible in vessel form. You're not limited by the chunk of stone that you have. You're able to expand beyond that. What's interesting, though, is that earliest versions of ceramics were not necessarily functionally superior to stone vessels. They, particularly in their lower fired states, we'll talk about here in a second, are not necessarily as waterproof, are not necessarily as resistant to heat. Many earliest versions of ceramics couldn't even be used over direct heat from a fire without cracking and being lost. So you have to wonder what kinds of processes might have led to their development and adoption by some people and their absence from other traditions. It may be that people develop ceramics in regions where they don't have good quality stone, soft carvable stone to make these out of, or where they don't have large sea mammals to make bags of skin to carry things in. It could be that. It could be any number of different factors, and it doesn't have to be the same reason everywhere. But this is a very, very interesting question to consider. Why do you see the development of ceramics in some places and not others? What prompts that initial experimentation and adoption of this new way of doing things? Remember, as we'll see here, some of the oldest ceramics are only about 12,000 years old, and yet people just like us have been around for almost 10 times that period. So only 10% of our species history have we been making ceramics, even in a couple of spots. So it has to be a question. It's not a biological thing that people make ceramics. What's also interesting is that there's a great deal of continuity of vessel form in these early ceramics. Rather than having completely new shapes of things, they usually take the forms, almost the exact form and size and shape of vessels made out of gourds or carved out of stone from earlier time periods, and they replicate that same form in the ceramics, showing that the ceramic is really a new material that you're making something out of, not necessarily a new idea. Much like you get pants. Pants are shaped like pants, whether they're made out of cotton, wool, or polyester. These are just different, or spandex, just different materials that you're making the same basic kind of thing out of. That might be the way to consider some of these things as well. It's not always true, but often. What's also interesting is that you have different kinds of construction. There's hand-built, coiled, molded, wheel-thrown. I'll show some examples of those here, as well as different kinds of temper. That temper is a grit or material that's added to the base clay of the ceramic in order to improve its thermal properties, so that as it's heated up and cooled down in the firing process, it doesn't crack and it's not destroyed in that process. And this temper can be fiber or shell, sand, ground ceramic, even mica that can make for a beautiful kind of surface to the material. And that surface can vary as well. You can have burnished, which is where the ceramic vessel is first allowed to dry a little bit until it's what's called leather hard. And then a smooth stone or other object is taken and rubbed against that surface of the stone, compressing that layer of material down so that it has this polished look to it. Very beautiful effect. And especially if there's mica in it, it lines that up so that the surface actually glitters. There can also be slipped surfaces where you take a clay and you create sort of a paint out of this clay and apply it to the vessel after it's leather hard, and then that's fired along with the vessel. Gives a matte finish to the decorations. Then there's glazed finish, which we're quite familiar with. This is where a high silica content grit is made into a paste or paint that's painted onto the surface of the vessel once it's dry, and then that's fired. And when it's fired, that sandy, gritty um, glaze or paste vitrifies. It turns glassy and imparts that glassy texture to the surface of the ceramics. But certainly not a universal thing that's done with ceramics. And there's different kinds of this firing, this heating up to achieve the effects that we're talking about. And this can be open, we'll show some examples there, or kiln firing. And you also have reducing or oxidizing firing, and it depending upon how much oxygen gets to the surface of the ceramic, it's going to affect the color and other thermal aspects of that process. You've also got coiled or built pottery. Here you can see coils are being used, and then a finger is being used to sort of bind those different coils together. Very, very common in early ceramic traditions all around the world, and very universal. One very early example of this is found among the Jomon archaeological culture of Japan, where we see some of the very earliest ceramics in the world, dating to as early as 12,000 years ago. These vessels were used some for processing and storage and were connected to environmental change that people were adapted to, but they were also extensively used in feasting and ritual and burial. And for a late Pleistocene, Ice Age society, the fact that ceramics had entered into so many different dimensions of Jomon society and use is incredibly advanced for this time period. And they're elaborated beyond simple necessity. This is not just a finger pot that somebody makes to um, hold some grain or whatnot. This is already at this very, very early date true artistry. And you can see here some additional examples clearly demonstrating that. No, that's not a space alien on the left. I know, I know. Another technique, which is directly related to paddle and anvil, or sorry, directly related to coiling, is a paddle and anvil technique, where a piece of large flat piece of clay is taken as the base to begin starting, and then coils are built up around that. And then a anvil is used on the inside to hold the vessel to form, and then a paddle is rubbed around the outside. And so this compresses from both the inside and the outside, allowing even larger vessels to be made with a coiled technique than could be if you were just using your hands or less specialized manufacturing tools. And you can see on the top right of the slide there an example of an open-fired ceramic from northern Baja California. And you can see what's called the fire clouds on this, because in this open firing you don't have as much control over where the airflow goes and where the oxygen goes, and so you end up with these very kind of fractal and beautiful patterns of oxidizing and reducing environments in the firing process. And finally, the kind of pottery that our society has been, in most societies in uh, Europe and North America and North Africa and the Middle East, South Asia, East Asia, have been making for at least the last couple of thousand years. And that's pottery made on a rapidly spinning wheel, a potter's wheel. This creates a great deal of symmetry in the material. It also, though, requires the use of a lot more clay than a coiled built model. It also would be not nearly as feasible to make some of those jamon pots that we just looked at using a potter's wheel, because it has to be cylindrically symmetrical in its dimensions. You can't have one part kind of larger than the other. You also can't really make an entire figurine. I suppose you could make parts of a figurine and then assemble it later on a wheel, but uh, even though it allows for the mass production of more standardized forms, in some ways it does constrain some of the artistic possibilities. And so much of the decoration that is added to throne pottery itself is coiled or hand built or mold made, as in the examples shown here. Here you can see an ancient Peruvian figurine mold on the left hand side. And even very recently in England, after the introduction of tobacco, you see these mold-made clay pipes, industrially produced, manufactured on a large scale, and made in these ceramic molds. And so, one of the things that's interesting is that for objects whose size is preventative of, in the case of a small bowl of a pipe, wouldn't make much sense to produce on a wheel, or in societies where the potter's wheel had not been adopted, mold made ceramics can actually allow for very rapid and standardized production of certain things. And so again, it's looking at why these things are adopted, why certain patterns emerge in different times and places. And it can be the 1700s of England or 500 BC in Peru, why certain objects would be made out of molds. Here's an example of a partially mold-made ceramic from Peru. This is moche, portrait vessel, one of many of this type from the region, and absolutely true examples of ceramic art at the world level. This is still a remarkable piece of work 1,000 years or 2,000 years later. Open firing, like I talked about, is where you basically place the ceramics in on a stand that's not going to fall apart and have them knock into each other, and then you surround them with the fuel that you're using, whatever that may be, wood or agave stalks, or in some regions, dried uh, bison dung or cattle dung. It just depends on what you're using. And then you set fire to the whole thing. It burns down, and what you have left at the end is your ceramics. What you're really worried about in an open firing situation is maintaining that temperature in a way that brings the temperature up relatively slowly and brings it back down relatively slowly. But you don't have as much control of that in open firing, and so that maximum temperatures that you're really able to go for are lower, because if you send up the temperature too high in an open firing situation, you're not going to be able to bring it down slowly enough, and the ceramics as they cool will crack and be lost. Which is why in areas where people continue to develop high levels of ceramic art, you get the emergence of kiln firing, where you have various kinds of structures, semi-subterranean, or in the cases shown here, built-up examples, where the ability of the potters to very closely control how quickly the temperature goes up and how quickly it comes back down, how much fuel is used, how many ceramics are in there, controlling the airflow in different ways, really enables them to push the envelope as to how high they can take the temperature, which allows for the production of much higher fired ceramics, which have different kinds of thermal properties, and eventually even to the development of porcelain, which is the most highly fired, the highest temperature firing of any, and it turns almost to glass entirely. There's certain kinds of ceramics in Mesoamerica, for example, in the early pre-classic, called plumbate ceramics, and they have a very high fire to them, and they ring when you tap the sherds rather than go thunk. So you can often tell the difference between open-fired ceramics and kiln-fired ceramics. But then being able to look at that and figure out more precisely what kinds of temperatures were being used by people in the past is really important. Here you can see 5 different versions of firing or kilns, and the different ranges of temperature that you see in those different versions. The firing temperature of the ceramic affects both the water tightness of the vessel as well as the archaeological preservation of the material. The more highly fired it is, the longer it's going to last. Very low fire ceramics may disappear simply because of the chemistry of the soil. Meanwhile, porcelain can roll around on the beach for centuries and you can still identify it as porcelain. Different clays, different sources of clay are amenable to different temperatures of firing. And like I've been mentioning, carefully controlling both the speed with which the temperature is increased and then decreased after firing is critical. Otherwise, the pottery will crack and fail during the firing process. And here's where that association, that frequent association in different parts of the world between metallurgy and smelting and ceramics really emerges, because some of the earliest examples of ironworking and bronze smelting, for example, are found in places where people have figured out how to work kilns, where they have developed ceramic technology to a high level, and their ability to control fire and its temperature in a much more precise way is probably what leads to the technical capacity to begin experimenting with different kinds of metalwork beyond simple cold hammering, right? Some of the earliest iron and steel working actually is found in Africa. And the Nok civilization in West Africa displays remarkably early and sophisticated metallurgy and ceramic technology. Most Nok sites date to between 1250 BCE and 2000 or 200 CE, over 3,000 to almost 2,000 years ago. So they're making working with these kinds of metals as early as anyone in the world, without having to get into the is it here earlier, is it there earlier. But just suffice to say that these African metalsmiths were doing this just as early as anybody else in the old world. And here are some examples of some of that early Nok metalwork on the top left and bottom right there, as well as some of their remarkably beautiful ceramic work that they did. In addition to your more commonplace vessels, these sculptures and figurines really demonstrate their both artistic and technical skill. And also in West Africa, you see the development of what's called a lost wax casting technique. What you do in lost wax casting is you create a clay core, and then you build up a layer of wax around that clay core, and you use different kinds of tools and molding to create a shape, to create a sculpture, a figurine, a vessel, whatever it is, and decorate that in this wax. You then take wax rods and a wax cup and attach that to this wax mold that you've made around this clay core. You then have a layer of clay and a layer of fine sand around this model. You create this mold and completely build up around it. You then fire that whole thing. and the wax drains out of the bottom of this mold that has now been fired and is now a ceramic mold. You then turn this whole thing upside down and you pour the molten metal into this ceramic mold that you have created. Then once that metal has cooled, you may have heard the expression, they broke the mold when they made so and so. You may not have heard it, but trust me on this. So when you break the mold, you are able to remove this incredibly detailed, incredibly finely made metal sculpture, oftentimes out of bronze, which is a combination, a smelted combination of copper and tin in some places, or in other places copper and arsenic, which is also a metal. Um, so you have this incredibly detailed, incredibly beautiful sculpture that you've created. But there's only one, because you had to break the mold to remove that piece of metalworking, which is why why it's called lost wax, is that you've the wax that you made this out of initially is gone, and so that's what's lost, and then you're casting it in the hollow space left behind. But each one of these lost wax figures is entirely unique. Even if one is very similar, it had to be made in a separate mold. Here you can see an example later in time, the descendants of these Nok metalsmiths. This is from the Ife state in Nigeria from the 11th to the 14th century AD, and it is also made with lost wax casting. And so you can see the incredible workmanship and beautiful artistry of these things. So that's sort of casting and smelting in different varieties. And then, of course, you've got forging, right? Classic example that I'll use here is that of Japanese swordsmiths, right? Making katanas, taking iron and infusing it with carbon, creating steel, hammering that steel and folding that steel dozens, sometimes hundreds of times over upon itself. And then the final workmanship on these swords is done with incredibly fine tools and incredibly fine polishing to highlight the beauty of that folded steel until you have versions like this as the final outcome. So beginning with cold hammering thousands of years ago in places like Varna and ending up with Japanese katana might be one way to look at this, but we have continued to develop our metallurgy. Material scientists are continually coming up with new forms of aluminum and steel and different kinds of materials that allow us to expand our technology and build spaceships and further push the boundaries of this. But this is a part of this ancient tradition that began way back when people were attempting to use new materials to make tools in different ways. And so the technical and technological leaps that were made possible through the incorporation of different kinds of materials like ceramics and metals into the human toolkit were pretty remarkable. But the artistic ones as well. Gold still has an appeal for us. Metals still draw the eye and are remarkable in the aesthetic qualities and the aesthetic effect that they have on many people, as well as beautiful works of ceramic. Thank you, guys. That concludes our lecture on ancient technologies and ceramics and metallurgy. I look forward to talking with you next time. Don't forget to come on the discussion board on the Canvas site with any questions you may have. And remember, we have office hours on Zoom from 11 to noon on Tuesdays and Wednesdays. I hope to talk to you soon. Be safe and